Now we're going to work through an example of designing a data definition from scratch using the How to Design Data recipe and the accompanying data-driven templates recipe. It's going to be a simpler example than the traffic light example you saw earlier in the week. What we're going to do over the next couple of lessons is build up our skills to designing more complicated data definitions like that. What I've got is the city name starter from the HtDD module webpage. And it says, imagine that I'm designing a program that, among other things, has information about the names of cities in its problem domain. Design a data definition to represent the name of a city. So the key first thing that we do when we design a data definition is to work out the form of the information we're trying to represent. And it might even be good to just write down a couple examples. Maybe I'll put a little comment box right here. And I'll write some examples. So one example city name is Vancouver, and another example city name is Boston, for example. And these are all information. And now the question is, how am I going to represent that? What I'm going to do is go to the course website, and I'm going to go to the design recipes page. And this again provides me an index into all the design recipes. And I'll go to the How to Design Data recipe. In this web page, I won't go through in detail now. I'm just going to work through it by example, but you should review it on your own. It tells me about the basic parts of every data definition, and I'll pick this up later and set it down off to the right when we're working in Dr. Racket. And the key thing it helps me do is decide what kind of data definition to use based on the form of the information that we need to represent. Now remember, we're trying to represent city names, things like Vancouver and Boston. And the thing about that information is that it's atomic. And what I mean by atomic is you can't take it apart into pieces that are still meaningfully part of the same problem domain. So yes, it's true, I can take the city name Boston apart into the letters B-O-S-T-O-N, but those aren't meaningfully part of a city name in a sense. They're not like neighborhoods of the city or something like that. So this information is atomic. And the way we represent atomic information is with a type comment that looks like this. We simply have a new type name, and we say what underlying primitive atomic data it's going to be represented as. So going back over here to Dr. Racket, I'm going to say city name is string. A good way to represent this information is using strings. So for example, if we do this, the data that represents the city name Vancouver is going to be the string Vancouver. And the data that represents the city name Boston is going to be the string Boston. So here's my type comment, city name is string. And now I need to provide an interpretation, so I type interp period. And for simple atomic data, the interpretation is often fairly simple, especially for a case like this. We're just going to say the name of a city. And now the next part of the data definition is something that we didn't see in the last example, and we'll talk about why that is more in a couple videos. But we want to provide some examples of how the data definition represents information. So what I'm going to do is I'm going to say define city name 1 is, well, one good example is Boston. And define city name 2, and another good example is Vancouver. Now, I'll be honest with you, providing examples of really simple data definitions like this doesn't do that much work. But again, we're learning the recipe now so that it'll help us more with more complicated examples. And fairly soon we'll have data definitions where the examples really are going to help us understand the data definition better. So there's the examples. The next step of the recipe is to produce the template for this data definition. Now to produce the template, what I do, I go back to the course website and I go to the design recipes page and I get the data-driven templates rules. So here's the data-driven templates recipe. And the way this works is it says for a given type name, the data-driven template looks like this. So what I do is I say define fun for city name, and we're going to be quite particular about the name of the template. Naming the template directly after the type name is going to turn out to help us quite a bit later on in the course. And I'll pick as a parameter name for this template CN. And now I've got to do something about the body here. And what I'm also going to do is I'm going to write template rules used like this. And now looking back at the data-driven templates page, what I see is the way to produce the body is to follow the rules in this table. What I do is I go to the type comment, I look at the first word after is, so that's string, and then I start working in this table from there. Now string is what's called an atomic non-distinct type. The best way to understand what non-distinct means is to wait for a couple more videos and then we'll see what distinct examples are. But string is right here, so this is the row of the table that I'm going to use, and I'm not inside of a cond. You'll see what it means to be inside a cond again in a couple of videos. But for the body, I'm just going to say ... x, where x is the actual parameter name. So the body of this template is just going to be ... cn. And I'm also going to write here the template rule that I used. And the rule that I used was the atomic non-distinct rule. And I'm also going to write the part of the type comment that matched that rule, which in this case is string. And now I'm going to run this. And there's nothing really to run, but the key thing is I didn't get any errors. If, for example, I had made a mistake, like I had left a parenthesis off there, then I would get an error right now. And I would fix this poorly formed template right now. So I'll fix this poorly formed template right now. And now I've got this running properly. And what I'll do is I'll comment out the template, because we're never actually going to call this template function. We're just going to copy it into later function designs. And I'll get rid of this now, this scratch work, because that's already really captured in the data definition. So there you go. I've completed a first data definition by following the how to design data recipe using also the data-driven templates recipe. In the next video, we'll design a function that uses this data definition.